We want to find out if this series converges or diverges. So with this one, we're going to use the ratio test. With the ratio test, we have a sub n plus 1. A sub n plus 1, absolute valued over a sub n. And if this is greater than 1, it diverges. If it's less than 1, it absolutely converges. Absolutely converges, which implies that it also converges. If it equals 1, then it's inconclusive and you have to do another test. So let's try this. Let's try to plug in n plus 1 for all n's and have that in a numerator. And we're going to take the limit, of course, as n approaches infinity. So limit as n approaches infinity of this stuff right here. E to the n plus 1 over n plus 1 squared. Here we have the original version, e to the power of n over n squared. So we're just multiplying by the reciprocal in this case because we're dividing. So it's the same thing as having e to the n plus 1 times n plus 1 squared multiplied by n squared over e to the n. And now we can start to cancel stuff out and grouping things together. So first let's group stuff together. So if we group stuff together, we have n over n plus 1 all squared, because this is squared and this is squared. So we can group them together and bring the squared outside. Now we have stuff that cancels out because this is e to the n times e over e to the n. So this cancels out with this. And we're left with multiplication by e of this. With this, we can solve the inside. We can divide everything by n in the way that we tend to do when we have a limit as n approaches infinity. N over n, n over n, 1 over n. This becomes 1, this becomes 1, this becomes 0 when we plug in infinity. So this is 1 squared, which is just 1. 1 times e, which is just e. So we get e. And e is clearly larger than 1, which means that by the rules of this ratio test, this diverges.